Let the team at Black Hills Information Security test your defenses. With over 10 years of experience in penetration testing, red teaming, and threat hunting, the testers at Black Hills will help you find the holes in your security before the bad guys do. The team at Black Hills cares about educating and sharing their knowledge by creating countless blogs, open source tools, and webcasts for you to learn more about the tradecraft of pen testing and red teaming. Visit securityweekly.com/BHIS to join their mailing list and view the latest blogs and webcasts from Black Hills Information Security. These days, it's rarely a case of if you'll be hacked and more of a question of when. Once the attacker has passed your defenses, they cover their tracks and systematically infiltrate your network to steal information or shut your business down. You need to rethink the way security is delivered for your digitally transformed business, and there's one security solution that delivers it all: NetScout. Get visibility without borders for consistent detection, mitigation, and prevention across any network, data center, cloud, 5G, and more. Learn more at securityweekly.com/NetScout. Welcome everyone. We're at Black Hat Day 2 of Black Hat 2019, and I'm very excited about this interview because we get to talk about firmware, which, as our audience knows, is one of my passions to talk about and nerd out about firmware. And with me to do that is Yuriy Bulygin. He's the founder and CEO of Eclypsium. Yuriy, welcome.
Hi, Paul. Thanks for having me here.
Yeah, it's nice to have you here. So for our audience, Yuriy, I know you and I have chatted before, and I love what you guys are doing. But for our audience, describe the problem that you solve.
Absolutely. Well, if we hear a lot about the software problems, software vulnerabilities, malware, ransomware, and if we take any device, there's a lot of software. There's operating system, applications, all of them have vulnerabilities, can be exploited, malware can get introduced on the device, but software is just the topmost layer.
Mm-hmm.
And if you look at each device, you have hard drive. It has its own operating system, its own software stack, network stack, well, potentially.
Mm-hmm.
Network cards, same thing. It has its own operating system, its own software inside of it. The BIOS, UEFI, embedded controllers, baseboard management controllers and servers that kind of manage or provide lights-out management of those servers and data centers.
And largely these are all firmware that exist on these specific pieces of hardware, right? Firmware in a sense that the kernel, operating system, file system is all bundled together and lives on this device inside the computer. Generally,
they have their own OS, their own code, a lot of code, millions of lines of code that manufactured by or developed by manufacturers of those components, and all of that is kind of embedded into those components, and that's what firmware
typically
is.
Not like Linux or something, or like it's firmware that we think about that we'd put on different devices, right? It's proprietary firmware, essentially.
Yes, can be Linux based, can be based on other operating systems, or can be completely proprietary. But there's just a lot of it. If you take just one component, let's say UEFI, that goes into any laptop, any server, it's not a monolithic piece of firmware. It generally has like 300 to 600 executables inside of it.
Wow.
Implementing full network stack.
It's like the undiscovered attack surface, right? As you described just how much code and how many applications are on there, it's a huge attack surface, and that's just one component you're referring to.
It absolutely is a very large attack surface, comparable to the entire attack surface of the whole software stack on each device. This is just one component, but if you take a server, it can have up to 100 components like that.
Right. And I think what also people may just not have considered and are thinking like old school, typically when we updated the BIOS, for example, we needed physical access to the system. And I truly believe that there is kind of that notion today that, well, I don't need to worry about the security because, well, someone had to be physically there. But you fast forward to today, the operating system has access to all of these hardware components and their firmware and software running on them, mostly.
Absolutely, and the reason is that because firmware is so complex, the manufacturers of those devices, they need an ability to patch bugs in that firmware, to patch security bugs in that firmware, so they need an ability to install updates through the operating system, sometimes remotely through other mechanisms. So there are plenty of ways to update firmware exists on every device. And a lot of those mechanisms aren't as secure. Some of them lack any security whatsoever. For example, signatures over those firmware updates. This is still a commonplace, and this is how malware and attackers are getting into the firmware.
And I think that's the other misconception. Is that, well, we've heard about these firmware attacks for a while, and no one was really doing that, but that's obviously not. You folks found some pretty interesting malware specimens that were running around on firmware, right?
Well, absolutely. There are implants that exist for different types of firmware. UEFI is one of them, but there are implants that exist for firmware on other devices.
And what was the kind of popular one that you guys were talking about in attack more recently?
One more recent one that comes to mind is LoJack's implants that was infecting UEFI. That was discovered in the wild. It was used by SEDNet, by APT28 group. It's an interesting piece of malware because it's not the new type of implant like that. We've seen UEFI implants before from hacking team, and there are indications for implants that were attacking MacBook EFI firmware from Vault 7 disclosures like dark matter and a sonic screwdriver. But this was discovered in the wild as part of a campaign, and it was exploiting a vulnerability to get into the UEFI and infect UEFI firmware. And the reason it was doing is to get persistence,
right?
Because even when you reimage the operating system, or you do any detection within the operating system, or you do any incident response, LoJacks could still reinfect the OS after reinstall and bypass those measures, those detection.
And it's the UEFI has basically unrestricted access to the operating system,
Absolutely.
Right? Which I think is an important point that many not consider. It doesn't matter what OS protections, like you said, are in place. It can just still reimplant itself.
Absolutely. It has full control over the entire operating system, entire software stack on a device, including hypervisor and VMM. For example, if you take Windows 10, which has a really great security architecture based on the virtualization-based security, based on a kind of a special version of a Hyper-V underneath it. The UEFI implants bypass all of that, including all the capabilities that are based on that virtualization-based security, and any other protection that is really implemented and enforced in the software. For example, we all think that BitLocker is a hardware technology, but the reality is BitLocker is really a software-based full disk encryption. It works with the TPM Trusted Platform module in order to in order to protect from evil-made type of attacks against the bitloaders. But if you have an implant in the UEFI, then you can still introduce that evil-made attack against the BitLocker and then capture the PIN or the passwords that user enter.
Now, given the risks that we just spoke about and the capabilities this gives you, the fact that we've seen it in the wild means that everyone's updating their firmware today, right?
I wish.
That's your goal, right?
Maybe we'll have some influence on that. But this is absolutely the first thing that we need to establish as an industry. It's the first. It's a basic hygiene.
Right.
We do that in software. There's so much firmware. We have to do that in the firmware as well.
Right. And I have a lot of theories, but I want to hear from you. Why don't more people pay attention to this and include it in their regular patching cycles?
It's a bit more complicated because there are many vendors of devices. They have their own update capabilities. Then there are different devices on each system, on each laptop and server. Those have their own tools and methods to update firmware on them. So there are hundreds of just the update tools.
Some of those update tools also have some pretty serious vulnerabilities. Was it Lenovo patched a vulnerability not that long ago?
The update tools are great entry to for attackers. Most recently, I think the Shadow Hammer campaign that was targeting ASUS live update utility that was delivering firmware updates on ASUS systems. But absolutely, update utilities are an important vector because their whole purpose is to update the firmware.
Is to interact with that firmware, right? So that's
any
one way
vulnerability.
in. Yeah. Also, I think people don't think about it. Like, they've got so much on their plate. They're like, I'm struggling to keep my apps, my operating system up to date. Things go wrong, I'm just going to wipe it. Now you're adding on top of that, how do they manage all of these different subsystems together? And that's what I love about your solution, quite frankly, to cut to the chase, is that it gives you that one unified platform that is important for security, but also for, general operations, right? I mean, having that visibility into what firmware is running, is it the latest version, are there bugs, is there security issues, right? And that's what
absolutely. And IT security teams and organizations, they're swamped with all sorts of things. And last thing they want is to try to find all of those 100 update utilities for firmware components on all of their assets that they have in their infrastructure, and learn how to use them to update the firmware. So what we are hopefully solving is taking that complex area and simplifying that for people who are tasked to protect their organizations. Simplifying by providing a one way to see the versions of the firmware, see what they have in their devices.
Right.
Including
do they have to put an agent? I can't remember now when we did when we chatted last. Is there an agent and agentless option?
Absolutely, we support both.
Yeah, that's what I thought.
They can run all the time and monitor each device in real time, or they can just scan device when.
And then it removes itself from the system, right? Once it does
absolutely.
that. Yeah, I gotcha. Now, the other thing that I like is, even if you use those update tools, some or all of them from the manufacturers, you're not going to gain visibility into, has my firmware already been Trojaned from the manufacturer or an attacker, after the fact. And that is a benefit of your platform. It's going to tell me about those conditions that maybe I've got some firmware that has already been, has malware inside of it.
Yes, because, doing basic hygiene in firmware is step one. But once you ensure that the firmware is patched, or sometimes you may not want to patch some firmware on your critical assets because you don't want server downtime or so. But once that hygiene is in place, or you kind of make the risk-based decision not to patch, then you want to monitor those devices if they have been really implanted, they have been compromised in one of those dozens of firmware components. Again, either in the supply chain or when a device is traveling or working out of remote location, or just as part of the operation, targeted by a campaign that uses firmware implants for persistence, like LoJax. So absolutely, this is our goal to ensure that those devices have not been compromised or tampered.
And you do that in a couple different ways. There's like a signature matching, obviously, but then you can also look inside some of that firmware and determine if there's components in there that indicate a compromise, correct?
Yes, we do look inside each firmware component, and also hardware components. And one of the effective mechanisms is for the firmware is to apply whitelisting, because firmware isn't like software that users install their applications inside firmware. They generally don't, and so firmware is relatively static from that perspective, and so we can ensure that all of the firmware components they have been really developed by the manufacturer of the device or
Right.
that component.
Even if they're not signing their firmware, you can still basically hash it,
Absolutely.
right, and
Yeah,
determine.
absolutely. And of course, we can apply other techniques like static analysis, like behavioral analysis of how the hardware behaves, and also detect known IOCs of known threats.
Yep. That's fantastic.
All of that applies, just like in the software. All of that applies to the firmware world.
That's awesome. If folks want to learn more and get a demo or a trial, how do they do that?
The best way is our website, Eclypsium.com, and I'm happy to connect.
That's awesome. Yeah, I've seen the demo. It's really fabulous. You guys have done a
Thank
great
you, Paul.
job. Great job. And I hope our audience goes and checks it out, because I feel like this is one of the sleeping giants that, like, when not as many people are paying attention to this as I believe they should. So
it is the biggest gap in the security today, I believe.
Awesome. Yuriy, thank you so much.
Thank you, Paul. Thanks for having me.
We're here at Black Hat 2019. I am here with the unicorn and Bryson Bort, the founder and CEO of SCYTHE. Bryson, welcome.
Welcome to my show, Mr. Asadorian.
If you were a Bond villain, would your name be Grimm?
Would it
Professor
be
Grimm?
Professor Grimm. Professor Grimm. Has a little bit of a ring. I never thought of myself as an academic.
Right.
I always, liked to do things.
It seemed you would fit the evil professor role, I think, very, very well.
Well, why is
Very
it?
well.
Is it the eyebrow?
It's just the demeanor.
The demeanor?
The level of intelligence coupled with the demeanor. Professor Grimm.
Well, I can fake intelligence when we're recording these things and then re-recording them. Like, this is what, our sixth take?
Well, it's good to have you here and do an interview live with the unicorn as well. We wanted to talk about some of your research and talks in the IoT space. I think we've got similar experience in that we looked at vulnerabilities and different methods of attack, talked about them, and then, like, lo and behold, years later, we're like, oh, yeah, look at that. Attackers are doing that today. And you've got a similar story.
Yeah. So 2 RSAs ago, I put together a talk called No IOUs for IoT. Because, 50% of a talk is the name, and that's what they accept you on. And then they're like, yeah, he wrote words or something. And I gave this talk at B-Sides Las Vegas last night. But what was kind of like the scripted for it was that just this week, the Russians were disclosed with their hands in the cookie jar doing the exact TTP that I've been talking about for the past 2 years. So, Boris, I'm watching you. I want royalties on that. And what they did is there were 3 classes of IoT devices that they hacked into, because where I was going with my talk is it's not the IoT device itself that most folks care about. Right? There's nothing really interesting on it. There's not a lot it can do unless you have lots of them, AKA what happened to Brian Krebs, where he was DDoSed across 1 million devices from a mass compromise. And that's the start for the talk, is I show how easy it is to get lots of devices. Because as an attacker, it's just surface area to start. I just want to begin somewhere, and I don't always necessarily care depending on what it is. Obviously, the Russians were probably a little more targeted, but kind of more the shotgun blast of what can I get in that sort of space. So what they did is they compromised these 3 classes of IoT devices and then used them to laterally pivot with traditional computer network operation offensive techniques into traditional IT enterprise, where there are things of interest, right? That's the data that I really want.
No, they weren't doing anything difficult, such as like creating their own firmware for the device and trojaning it and then uploading it. That was some of my things I talked about, because I liked the Hollywood script kind of style behind that. Like, it'd be really cool if I could modify the firmware and then Trojan it and then replace it, and then the user would use the IoT device. They'd have no idea, but I'd secretly be listening. It's not even that complex.
Not even that complex. And I was just thinking of our personas here. The next time I come on Security Weekly, I'm going to have to wear like wire rim glasses for Professor Grimm.
Yes, Professor
And you
Grimm.
clearly have the Hollywood glasses.
These are my Hollywood glasses. Yes.
No, that's the thing. You don't even have to be that clever. If you look at the threat landscape of what we've seen, these are consumer devices with mostly consumer-grade security, and that statement alone is pretty much an oxymoron.
Right.
And so the biggest attacks that we've seen have worked because most IoT devices ship with default credentials. So here's something you don't monitor. The consumer's definitely not paying attention. there's no lockout if I try to log into it too many times. So there's, kind of like 10 default password combinations of user ID and password. And
most devices today, because I think they're more powerful, you do end up with a shell. I feel like 10, 15 years ago, like getting an actual shell, like that wasn't even included on the device because it was so small. But today, that's possible.
Yeah, I get shell. They have a communications protocol of some type. I love it when I get TCP/IP because that makes it much easier for me to do those kinds of things.
Yep.
In the case of the Russians, they did TCP dump, which of course was available because I had that. That's there. And so as they've gotten increasingly more sophisticated, slightly more sophisticated, they now do have those kinds of things that start to bleed a little bit more into the traditional offensive operations, and I can take advantage of those. And so what we showed in, that first kind where I'm gaining access to get that shell with default credentials, and then the other part of it is the fact that, and you can go on GitHub. Right, I actually show this as a part of my talk. Go on GitHub and just look for proof of concept for IoT vulnerabilities. So these are, folks out there who probably have responsibly disclosed it. But there were 28,000 commits that I found. Wow. So you don't even have to know what you're doing. Just copy somebody's code. Make sure it matches the device. By the way, Census or Shodan will do that for me. So I get the exact firmware. I get the device, and I go, does this match this? It does. Drop the proof of concept that I'm on. I've got shell, right? I didn't even have to do anything other than just establish a connection to your IP to be able to do that. And you're on, right? So with no technical talent, you can actually take over all of these devices. And then it's just a simple script to run and be like, well, what can I see? Because I have that capability that's on that device to see what other things are on it.
And basically, I have a Linux box on their internal network.
Bingo. Yeah. So now I've got Linux. It's not running Kali. It's running some...
You're limited, sure, depending on the device. Yep.
Some janky Linux that probably was built by somebody who doesn't even exist anymore.
You could probably go on GitHub and find binaries for that. You don't even have to cross compile, which makes me want to tear my eyeballs out. You can save that step.
That's called convenience, Paul.
Right. Go on GitHub and just pull the binary and upload it, and now I'm off to the races.
Yeah. So people don't patch these things. People aren't monitoring these things, and they're out there with incredibly vulnerable to both of those approaches. And again, once you're on, you now have this enhanced capability to go back to your traditional penetration testing, red teaming, or nation state offensive operations.
I mean, very easy to hit file share, start probing the domain, right?
And that's what I do. That's what I do in my talk. Is I just start doing that, and then from there, in the particular demonstration, I do an end-day exploit. And I'm able to get the password decrypted. I then just do dictionary-style attacks against the file shares that I see with combinations of that password because most folks don't change it. And at that point, I'm on. And
some devices even have information about the domain. Like a printer sometimes will have information about the domain, so I don't even have to scan and broadcast. It's just there for me to look at.
Absolutely. And so, again, consumer environment, nobody's looking at it. Enterprise environment, theoretically folks are, but usually they get a little bit confused when IoT devices are starting to do these things because they do it a little bit differently, and then it just sort of is ignored. And that's I try to go into that talk with a lot more detail on the enterprise response, both at a policy and a technical level of what you have to do to really understand that piece. It's like we're going back to the 80s, and let's start figuring out everything that's going on our network again.
And I always said, with an IoT device, like a printer or whatever it is, it doesn't have a monitor, mouse, keyboard. There's no user sitting in front of it. There's typically not very good logging. It's not being monitored like a server or a container process even, right?
Not at all.
It's just kind of there. And no one, like you said, no one's really paying attention to it. It's the perfect playground for attackers.
And that's why I've been demonstrating that for the past 2 years until the Russians got using the techniques I was talking about.
Yeah. Now, in your space, in breach and attack simulation, right, and from defenders in general, how do we deal with the IoT, this device that we've basically just established as it's there and no one's paying attention to it? How do we get people to pay attention to it? What do they need to do?
So this fits nicely with our hypothesis. As the IoT device itself is, it has no organic value, right? I'm not doing anything on the device of interest. It's what I do from the device that's of interest.
Right.
And so I classify that into the way that I look at the whole kill chain of the problem from a defensive perspective, which is fundamentally me being on an IoT device in your environment is the same thing as me having gotten initial access to anywhere else in your environment. So from that view, just looking at it conceptually, it doesn't matter, right? I haven't accomplished anything as an attacker yet just because I've exploited a desktop that's not my final destination, or that IoT device or whatever, because at the end of the day, I land, I try to figure out where I am I safe? And then I start looking at what's of interest. What do you have that meets what I want to do?
Right.
And
so it's more about detecting and preventing the lateral movement than it is the initial infection. I mean, that's really what security is about today, because we know attackers are going to get in somehow, some way if they're persistent enough. And it's about detecting that lateral movement or preventing it.
And
or modeling it.
Or modeling. Well, we don't just model it, we show it.
It's not even a model, right? You actually do the lateral movement so you can understand how this would happen.
Yes, and this is where I saw us as a unique solution in the breach and attack simulation space is one, I mean, this goes from the couple of decades of real offensive experience that I have. Several of the folks on my team have worked for me in those places before, and we've been doing this for real for a long time. And so it was really fun to kind of be like, oh, let's just do this commercially.
Right.
And that's where our platform is different is this thing is going to come in and it's going to work just like a real attacker. It's going to be able to build itself up. It's going to be able to modify itself. It's going to be able to look around and take the information so that it can move through your environment to what's of interest from that adversary's perspective that you're simulating. It's not modeled, right? We're simulating in the production environment to see where does it get to something of interest.
Right. And how does it get it out?
And how does it get it out? Because we need, once I've got on that box, the clock starts ticking for measuring the metric to when the security team can identify what's happening. And every time I'm doing something, I'm providing that data point to be able to determine that. And so as this thing's moving through, those are, it's building up the log of where you should have first identified and figured that out, just like a real red team. Only this case, it's able to be doing it against, concurrently against the entire enterprise all at once through a common operations
And you've added
portal.
some more automation for that lateral movement recently too,
Yeah.
right? So you could basically like script the attack once you get in and laterally move.
Yeah, so we'd already had a lot of the capabilities to support lateral movement through different kinds of escalation of privileges and techniques for that, credential theft, Mimikatz. There were a lot of ways that were already there on the platform, but what we did in response to user demand is we actually built an automated workflow for that when you're building out the synthetic malware that you want to test with. And so the user can now sit there and be like, all right, well, I want it to be able to, once it does this, I want it to be able to take this information, then try to do that, and then try to worm its way through. So it will then laterally move itself, right? I'm going to use that successfully over here. And the other fun part that I like is it now includes what we call a battlefield visualization. So you can see the whole network of compromised hosts and how you're able to move through it and what it's doing at each point visually through the console.
Yeah, that's awesome. Well, because I think a lot of us, whether you're red team, blue team, right, you're like, well, I read about or someone told me about once they got in, they did this and Mimikatz and then this and this and this. Now you can just string that together and go, yeah, see what that looks like on my network.
Yeah, that's where I think we are bringing a real purple solution to the market, right?
Yeah.
We came from the red and the offensive side, but there's a significant benefit and a way of bringing that collaboration that we've talked about always about how do attack and defense play together. Well, in this case, what you build up here on the attack side, you can share that directly through the same platform so that the blue team afterward has that malware with all those things built in to now go, okay, well, let's test this as we continue to try to figure out how do we refine our detections. Did these controls work? Like, I can continue to do that. And then the other...
I like it. It's kind of like agile development, but for your infrastructure.
Absolutely. And that's another area where we see kind of like it even sort of a little bit further out there is imagine DevOps now being able to include that as a part of the testing for what they're going to be releasing, right? The part that needs to work is this thing needs to be easy enough to use that I, as a developer, don't want to understand all the intricacies or make this thing hard to use, right? I just want to be given, here's some specifications, here's a binary, what happens, right? I click the binary and I see what happens, or I inject the DLL and I see what happens, right? Like from my view, very simple things, and all of what it does is just baked into it, so I don't have to worry about it. It's like running an automated regression test, only with, offensive synthetic malware.
Well, yeah, I mean, regression testing for security, which is important. I mean, I feel like everyone should. I wish I had that in my DevOps chain right now. I'm working on building it. Maybe we should talk after after this interview. So
after I finish compromising your webcam, I'll do that.
Okay, perfect. macOS support is included now.
Yep.
So now you got Windows, Linux, and Mac covered. That's awesome. And if people want a demo or a trial, they can go to, is it securityweekly.com/Scythe? That's the works. SCYTHE.io. Right?
Yeah, pretty sure. I mean, direct to SCYTHE.io. We like our tech to speak for itself. I mean, as much fun as it is to get the dog and pony show.
Right.
I think it's no better than we'll give a free trial and.
That's right. You do have a free trial.
We do free trials.
Okay.
Right.
Yeah.
No, we like the tech to speak. I mean, we've created. We're the only folks on the planet who've built this right now. We keep looking. We haven't seen anybody else who does just-in-time compiled synthetic malware to specification.
Yep.
And so that's a strange concept, and more folks are starting to get it, and we're building a customer base, and we have more customers, as you and I were joking before.
Awesome.
You're like, what's different? I'm like, well, now we have more people paying, and you're like, well, what's going to be next?
More people.
Yeah. So we've already, we're getting onto, a couple of hands and toes of folks who use this regularly and pay for it. But going back to the point, we want you to play with it, right? Just free trial, try it out.
Right.
And I think the most common use case we get is because, what can I do in 2 to 4 weeks when you already have a full job and you're doing all these other things? Typically, folks are already, there's some procurement for some other security application or something or appliance, and they use our platform to validate it.
Right. Yeah.
And so our platform has become the most common trial we've seen is folks doing bake-offs using our platform to see what works or doesn't. And the best part about that is it's not like a lab setup of here's some artificial things that we're going to run to test if this EDR does this or does that. They can employ it in their environment under their own configurations and see what happens on the host and network at the same time.
It's awesome. Bryson, thank you so much for coming on Security Weekly.
Thanks, man.
Welcome to Security Weekly. I'm your host, Matt Alderman. This is day 2 of recording live at Black Hat 2019. We are at the suite of Mandalay Bay, and joining me for this interview segment is Dan Cornell, the founder and Chief Technology Officer for Denim Group. Welcome.
No, thank you.
So I love this topic, injecting SEC into DevSecOps. Right. A lot of people talk about DevSecOps, but I think very few really understand what it's going to take to make DevSecOps work. And the way I've always framed the issue, and we'll get into this discussion quickly, is on one side you have DevOps looking for speed and agility, and on the other side you're looking for security to understand, is the app secure and compliant, right? And those two don't always mesh well when you think about bringing the speed and agility of what DevOps is trying to do with kind of our old processes of security.
Right.
So let's start there a little bit and start talking a little bit about some of the challenges you see when it comes to security in DevOps.
All right. And so the way that we look at it is even taking a step back from that to ask, how have we gotten to this point? Why are we doing DevOps? Why do we need DevSecOps? And it's a bit of a overused marketing term, but a lot of it comes down to what we see in organizations is this push for so-called digital transformation. And what does that mean? It means we need to be able to quickly in an agile manner react to business conditions. We need to be able to move faster and innovate more than we were before. And so you look at organizations that are successful at this, and that's really required to stay afloat. Organizations that fail to do this, it's an existential risk, right? So security people have, in a lot of cases, a somewhat narrow view of risk. We don't want breaches. We don't want confidentiality, integrity, availability. From an executive level, it's a question of availability of the business, right? I mean, ask Kodak.
Revenue,
Ask Kodak how their digital transformation initiative went, and there's nobody to answer that because it didn't go well.
Right.
And so what we see at the executive level is this push, and we've got to move faster, we've got to be innovative, we've got to be responsive. That then gets pushed to the technology teams. We're going to make this cultural change to DevOps, and that's, I think, an important thing to understand is DevOps is at its heart a cultural change of we're going to break down the barriers between the development teams, the operations teams, so we can iterate faster. That then pulls in a lot of technologies, cloud, containers, serverless, all of these new
Kubernetes, all kinds of stuff.
All that stuff, because that's at a technological level what's required to be able to cycle quickly. And we also see adoption of new techniques like continuous integration, continuous delivery, CI/CD pipelines.
Right.
The security people, a lot of the more traditional security people that are watching this are like, what the hell is going on? Like, what are you doing to me?
If they even see it coming. See, that's part of the other challenge.
And I think that's a great point. And for the smarter, the leading security people, they see this and they can read the tea leaves and see this is where the organization's going. They're going to be doing a lot of things that are super uncomfortable for me because I'm used to my annual pen test, my quarterly code review, whatever the template.
My monthly vulnerability scan.
Exactly, right. And the more traditional like security curmudgeon that's like whenever anybody comes and says, well, this is what we want to do, it's like, well, fill out this form. No, you can't do that, right? Those folks are getting marginalized because at the C level, they're saying we need to go this way because if we don't, business isn't going to be around. So I don't care if we're PCI compliant if we're like laying people off and shutting the deal down.
Yeah.
The smarter security folks are looking at this and saying, we see where this is going. Let's, from a security practice standpoint, let's skate to where the puck is going.
Yeah.
And let's find a way to use this transformation that's going to happen whether I want it to or not. Let's find a way to use this transformation to accomplish the goals that we have, which are, again, confidentiality, integrity, availability, compliance, and so on and so forth.
Right. So I think what needs to happen, I want to get your take on this, is we need to start thinking about integrating security capabilities earlier in the DevOps pipeline.
Right.
Basically right from the time of code check-in, and have to integrate a set of tools. I don't think it's one. I think there's various tools that come along in that chain that allow you to pass certain gates in a more automated fashion to do that base validation of security and compliance. So from your perspective, where do you see those different tie-in points? Because I think that's what everybody really wants to understand is where are those points in the process that I should be tying into security and what kind of tools should I be looking at?
Right. And so everybody wants to shift left, also a term that's been just like savagely beaten beyond anything that it ever deserved. But that's the idea. Like, how do we get security meshed in with what we're doing, move it earlier in the process so that we, at the end of things, we're not doing security as the last thing. Because, again, in a continuous world, there isn't an end of things, right? It's not like, okay, we've got our quarterly deployment coming up.
Because if you did that, you would be doing it multiple times a day.
Exactly.
Right? Because of the release cycles are potentially multiple times a day now.
And also what we see with the new technologies, cloud, serverless, all those things, that makes everything much harder. It makes things easier for developers or give them a lot of options.
Right.
From a security standpoint, it's a nightmare. We didn't solve, as an industry, we didn't have a good handle on application security when we were looking at monolithic line of business apps.
Right. Single language monolithic apps that went through a waterfall process. We did a horrible job protecting those. Now we break these things up into mini pieces, right? Distribute them in various places, multi-cloud and hybrid, on-prem, etc. And they're multi-language. Yeah, we made it really more complex.
It's a clown show it's a nightmare for a lot of security folks. And and it's interesting because there's a lot of talk in the industry, especially in the federal space, but in general, about like the software bill of materials, right? And that makes a lot of sense for these monolithic applications. Okay, for this application, what open source do we have in there? What are the different pieces? But when you look at these modern applications, like really you've got to have an architectural bill of materials. And a lot of that starts with a threat model to understand what are the pieces of the system, how are they talking to one another, and for each of these pieces of the system, what are the things that roll up into that?
Right.
And the way that we look at it, and this is evolving, but is for each of these chunks, you've got, I call it the 4 C's, for lack of a better anything, but you look at, you've got code that you wrote. Right? So this is the custom logic that you're doing that's doing something valuable. That then pulls in different components, open source components that are doing the frameworks and are doing different commodity tasks. That then sits on some type of compute, whether those are fixed servers, which are going away, but not as fast as anybody thought. Whether those are virtual machines, whether those are cloud servers, or if they're containers or serverless, right? But there's something that is executing all of this stuff. And then all of that lives in a cloud environment where you're concerned about the configuration. And so are my S3 buckets
configured correctly? So I'm not leaking data.
Right. What are my IAM permissions between these chunks and AWS and whatnot? And so when you take a step back and look at, here's all the stuff that rolls into this particular application, the different services and whatnot, then you look at a CI/CD pipeline, and the question is, how can we provide insight earlier in the process with that?
Right.
And again, so you have things that will scan code, static, dynamic, IAST. You've got the software composition analysis that lets you look at components. You've got your network and infrastructure scanning that looks at compute as well as some understanding of the container vulnerabilities. And you've got cloud configuration that you can check to look for known misconfigurations. And so there's a lot of data sources that you have, that you can potentially check very frequently, on each check-in.
Right.
The question is, what do you do with this information? Everybody, I think, in a perfect world, security would love to be able to stop the pipeline, right? Like the Toyota assembly line, this part's not right. I'm going to pull the thing, and everybody's let's fix this problem before it goes on down the line. From a pragmatic standpoint, from just looking at the politics in an organization, security folks got to be real careful about when and how they do that. Because
the business is going to move forward.
Exactly.
And it better be the right decision, because if you slow down the business, they're not going to let you come back the next time.
Exactly, right? Everybody gets one, right? and that's what we see with a lot of technologies, web application firewalls. Let's put it in blocking mode. Well, let's stop this transaction. Okay, well, let's just put it in listen mode. And we'll look at the logs. Never.
Right. The same thing with IDS and IPS.
Exactly.
We never put them in blocking mode.
Exactly, right? So just hey, we're watching this stuff go through. Bad stuff, guys. Is anybody listening?
Alert. Somebody over there in the SOC handling that?
Anybody? And so that's something that I think security folks need to be cognizant of, is they have a role to inform the development teams of problems, and if they can do that earlier in the process, that's tremendously valuable.
Right.
To look at blocking, you've got to be very judicious about when you use that power. With the Spider-Man, great power comes with great responsibility, and for security people, with great power comes don't mess up, or else you're not going to have great power anymore. And so that's, I think, important for when we work with security teams in looking at this. Okay, you want to provide information early, but be very careful about when you want to step in and stop the process. And I think it's also important to realize that when you're running these tools or different tools or different scanning in a CI/CD pipeline, that's not the sum total of your security program. That's something that you're doing, again, to provide...
That's just the application piece of the pie, right?
Exactly.
Yeah. Because there's more to it than that. That you still have data security in there. You still have at least identity and user requirements at a bare minimum. And then it depends on where you're running. You may have more. But that's just the application component.
Exactly. And if you look at the type of testing that you can get into a pipeline, you have to provide results that are available quickly. What we hear in some environments is security has an 8 to 12 minute time budget of this is what you get to weigh in, and that varies in different environments. But it's important, I think, for security to look at testing in a pipeline. What's your time budget? They also have to provide results that are of high value to the dev team. Right. So is the developer going to look at this and say, "Oh, I'm glad I know about this now. Let me fix that before we move on down the road"?
Do I have a malicious component that I pulled down from my Git repository? Oh, there's a newer version that resolves that vulnerability. It's an easy swap out. Done.
Exactly.
Right.
Exactly. Versus, you've got XYZ. This is a medium. Maybe you're worried. We'll sort that out. We'll sort that out in bulk or in a batch later. And they also, this goes back to if you're actually blocking the pipeline, the results have to be right. You can't be sending results to the developers that have false positives and things of that nature, because again, that's a great way to get marginalized. And so the type of testing that you do in a pipeline is not the sum total of your security program, because you probably have, at certain checkpoints, okay, we're going to do a more thorough static or dynamic analysis. This is when we're going to send in the manual pen testers that are going to work on this. And so I think it's important when you look at integrating into pipelines, what are your goals for that? And understand that that's not going to be the sum total of your software assurance or your application security program.
So I think you hit on 4 points that are really interesting. code, static analysis traditionally, components, software composition analysis, 2 easy points in the pipeline to check, compute, not as easy sometimes, right? Because those scripts are getting developed and spun up on the fly. There is some interesting technology starting to come around that's starting to look at some of those configuration files to make sure things get spun up correctly. Right. Same with cloud, right? It's all about configuration in cloud, really. I think that's where we see the biggest security gap when it comes to cloud is misconfiguration. That's what allows hackers in. I mean, Paul left his API to his Kubernetes environment open, and somebody spun up a container in that environment, right? I mean, that was a misconfiguration. It's an oversight. So where does Denim Group then, are you then helping your clients really kind of figure out that journey of all those little tie-in points? I mean, is that really where you guys are focused?
Yeah, I mean, so we provide the advisory services around that, the testing services, as well as the advisory services around. Here's how you, in your environment, given your regulatory situation, given culture of your organization, these different factors. Here's how you can position yourself for success. And then obviously the testing services associated with that. And then we also have our thread fix platform that pulls in a lot of this data and allows for a central point where security teams can see this is the tempo of testing that we've been seeing, these are results that we've got.
Good.
This is how we've communicated these to the dev teams, and allows you kind of that view across the teams across the teams around your organization, because that's typically the organizations that we're working with are have teams around the world developing software, multiple applications, multiple testing technologies. Right. Just demographically, that tends to be the folks that we work with.
Yeah. And so you're actually helping customers bring the promise of DevSecOps to light. Let's hope.
Right. I mean, and helping, and as we talked about earlier, for a lot of the more traditional security folks, like this is.
I know.
It's scary because it's not the quarterly, it's not the annual, it's like suddenly this is continuous. But again, it's a question of how can we stay relevant? How do we maintain our seat at the table? And for the leading security folks, how do I use this transition as a way to get myself into the process? How can I hack this digital transformation initiative to make sure that I'm accomplishing my goals, which are compliance and security and things of that nature.
I always tell when I always do this talk, I said I said you find out if you have a DevOps team, and then go talk to them.
Right. And that's
let's start with just basic communication.
Basic communication.
Just the fact of realizing, oh yeah, I have one of those teams, and maybe I should go find out what they're doing because I better be informed to know how my security program needs to fit into what they're doing.
Right. And understanding, I come out of a software development background. And that's a lot of the stuff that we've done at DenimGroup obviously reflects my background in software development, and so I am fortunate in a DevSecOps world in that I did a lot of software development.
Right.
That lets me talk developer.
Yeah.
A lot of security folks came out of an audit or a pen test background,
or a network security background.
Exactly, and so it's not a given that they understand. Well, hey, what's an integrated development environment? Why would I want to use Kubernetes?
Right.
Like what? How do you defect trackers? Jenkins, CI/CD pipelines, and so that's in a lot of cases. There's an education component or a self-education component that security folks need, and that's a great way to do that. Is introduce yourself, buy somebody some lunch, ask questions, and hear the answers.
Yeah.
And that's something that that ability to understand not your enemy, but understand the people that you're trying to work with.
Right.
Given that understanding, that's going to make you a lot more effective in working with those folks, because you can say. And another point that I think is really important to make. From a curmudgeon standpoint, there's a lot of focus on, those developers, they don't care about security, they're just doing whatever they want. Those guys. The developers that I've worked with care about security, but they also have to care about new features that got promised by an important VP to an important customer, right?
Their requirements are really business driven. Right. They're not security driven. It's not that they don't want to build secure code. They may not have time to build secure code. So if you give them effective ways of tooling to check along the process and give them the information back, I think in a very efficient way, right? Tied back into their developer tools, right? Maybe it's a Slack or a HipChat or a Jira ticket or whatever. But if you understand that I've got a critical vulnerability, it's coming back into a tool set that they're using as part of developing against their requirements, they're more likely to fix that thing right there because they have the data. It's really easy for them to do it. And that will result in better secure code down the pipeline instead of waiting to the end of the pipeline, which is where we traditionally are.
Right. And we've seen, just from some of the environments we've looked at, we've seen like a 44% decrease in the mean time to fix for vulnerabilities when you communicate with developers in the tools they're already using. And so that's a very powerful metaphor.
Yes.
Because too many organizations are still, hey, I did some security stuff, and here's a
here's the
300-page
port.
here you go. I put sticky notes on the stuff that I thought was really bad. Like, thanks. I have a special drawer, like really low in my desk that I use to file all of these reports that I get from you security guys.
Yeah, and it's aligned with a trash bag.
Yeah, exactly. It's actually the shredder. Thank you. You have another report?
Right. Integration's important.
Right.
If people want to learn more about Denim Group, where should they go?
They can go to DenimGroup.com. Obviously, main website. We've got a blog where we post a lot of this stuff. Folks that want to know about the ThreadFix platform, it's threadfix.it. Get it? ThreadFix it.
ThreadFix it.
That's clever.
Nice.
They can follow me on Twitter. I'm at Daniel Cornell. And talk about these things on Twitter. And reach out on Twitter, reach out via the web. We're always happy to talk about this stuff.
Awesome. Thanks for joining us, Dan.
Thank you very much.
Thanks for joining us, and we'll see you soon.